So, can you graph a square root function? Hopefully by the end of today that will be the case. And we've got just 3 examples to make that happen. So, it's all right, Andrew. We can talk about that in a little bit. All right. Don't want to get you behind here on what's going on. The basic square root of x. It doesn't get any more basic than this because we're only doing one thing. We're just trying to find the square root. So we want to create a table of values so we can see all the values from -1 to 16. And again, calculator is going to help us see all that today. So we're going to press the y equals button, and we're going to use the square root key, which is second x squared. So the opposite of square rooting a number is to square it. And then we have to use the variable key, which is right there. So the square root of x, that's all we're trying to do. Now, can we see all of these values at once? We can. Second graph and looking at the table. So this is like the fastest way to see all the answers for this x column. The y values being the outputs. And so Andrew asked about a negative number, and look at that. It's an error. And if you look even further back, they're all errors. Because to take the square root of a negative number, it's impossible. There's no way you could get to the square root of -4 if you multiply the same number times itself. And you're probably saying, well, what about a -2? Well, even if we had -2 and we squared it, remember that that actually makes a +4. So there's no possible way of getting a negative square root. Just can't happen. And we'll talk about that in just a second. But for right now, we want to write these values in. Okay? So we're going to fill out our table starting at 0. Well, actually starting at -1 and saying that this is an error. So let's just go ERR, not possible. Square root of 0 is 0. Square root of 1, we're just pulling these right from the calculator, is 1. Whoops, there we go. And then we do the square root of 2, which is not a perfect square. Sounds like it, but it's not. And that is 1.4. And we're just going to do to the 10th place. We're not going to get crazy here. 1.7. Now the square root of 4 works out to be plain old 2 because 4 is a perfect square, so it gives us a whole number. Those will be the ones that we end up graphing. We're not going to have to worry about graphing these decimals. Then we go 2.2, 2.4, 2.6, 2.8. All right, so 2.2, 2.4, 2.6, 2.8. And as those decimals get larger, we're approaching the square root of 9, which, yes, in fact, is 3. And that is a perfect square, so that's why we got a whole number. And now let's use the calculator to go down a little bit further and see what, oh boy, here's where it's got a mind of its own. A little bit of a delay, and it took off on me. Here we go, back to like 10. There we go. 3, 1, 3, 3, 3, 4, 3, 5, 3, 6, 3, 7, 3, 8. So getting obviously closer to 4, slowly but surely. 3.1, 3.3, 3.5. I think it did go 3.6, 3.7, 3.9. 3.6, 3.7, 3.9. And then it did the square root of 16, and then that would be 4, because 4 times 4 makes 16. So why are there no outputs for negative x values? You can't take the square root of a negative number. Okay, correct. Can't do the square root of a negative number. What is that? How did that come up? Values gave whole number outputs. Keeping it simple here, the perfect squares. Remember those numbers? The ones that are so perfect. And let's go ahead and graph this, because then we can answer what shape it looks like. So graphing this, and then this is just the first quadrant, a little bit of the fourth quadrant down here. So this is 0, 0. This is where they meet. And then it's 1, 1. So 1 to the right, up 1. And I'm using just the values that I have here So just these ones. I'm going to graph this one because that's two whole numbers, and I'm going to graph this one and this one. I'm not going to worry about all the decimals, okay? That we're just kind of trying to show us that those numbers are irrational. They're never ending, never repeating when you do the square roots. So now we got to go out to 4. 1, 2, 3, 4. The square root of 4 is 2, so go up 2. Go all the way out to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. So there you have it. So you've kind of got this shape right here, which doesn't look like much, but I think with my smartboard magic here, I can do some fun things with this, like this. Okay. And can I move it? Yep. And I know that you can't do this with your paper, but we're like half of a parabola away, right? So remember that the parabola is formed when we are squaring things. So it's only natural that this is going to be half of that parabola. Let's see if I can get it back to where it should be. So there you go, a little bit of clear touch magic. I used to call it smartboard magic. Now it's clear touch magic. So half of a parabola is a square root function. I'm just going to use my finger here. All right. Oh, what the heck was that? That's not what I wanted. Let's undo that. I want the pen and just black. How about that? And I got my tools back. Excellent. I didn't have intro. We found that we can take the square roots. Obviously, there's only some numbers that we really want to focus on. Those are the ones that gave us whole numbers. We can't do the square root of a negative. We can only find the square roots of we can only graph the square roots that are perfect squares. And we made half of a parabola when we graphed it. It also was on its side. So let's take a look at what we got next, because there's only 3 of these today. Shown is that basic square root function. So that's already down there. We want to go ahead and we want to graph this one right here, which has got a few more parts to it. So it's the square root of x plus 4, and then outside of that square root plus 2. So I'm going to do this the old way, just to kind of prove something to you. I'm going to take this number and substitute it in for x, because that's what the calculator does. So we're going to go g at -4. This is the fancy way of showing you this. I plug in the x value, so -4 plus 4, inside the square root, outside of it plus 2. Now we just got done saying you can't take the square root of a negative number. Negative and 4 here, the number we're using is -4. So is this going to give us an error? Well, because we are adding first, this is actually going to make the square root of 0. -4 plus 4 is 0, and then I'm still adding 2 after that. So because that we had a -4 and we added 4, we got 0. The square root of 0 actually is 0, and 0 plus 2, well, that's just going to be 2. So be careful when you think of this as an error because it was a negative number. We might sometimes add or subtract in this, and that might have an impact on what numbers we can use for an input. Okay, so 2 is the first number here, and then we're going to try to find the others with the calculator. So back to the calculator, back to y equals. I'm going to clear this out just so that there's no confusion here. Morning. How's it going? It's going good. We're typing in second x squared for the square roots. We're going variable key. We are adding 4. We're getting outside of the square roots and then adding 2. All right. So there it is typed in. We really want to see the values that creates. Second and graph. Now, we want to go in the table until we see errors, until we can't see numbers anymore. And there's the first one. So at -5, it created our first error. And we kind of proved that because at -4, that's what made the 0 in the square root. So then after that, all the numbers would be things that you could actually try to graph. So then -3, 3 is what we're going to put in our table. -3 gives us a +3 for an output. And the graphing calculator, we're only going to focus on the ones that were whole. So 0 gave us a 4, And we could have shown you this, doing it the long way, but the calculator is so much faster. And I'm kind of telling you this with the next one. The next one's at 5. Irrational, irrational. Finally, we get 5 at 5. And the next one that we can graph is at 12. 12 is 6. Okay? So we got 5 here and 6 there. So enough values to go ahead and graph. So let's do that. Gonna get rid of my little work here. And I'm going to go with a different color. How about that? So the first one up is -4 for the x. 1, 2, 3, 4 to the left, and then 2 for the y. So left 4 up 2. Just did this first one here. Then -3 and up 3. 1, 2, 3. And 0, 4. 0 left or right, up 4. And then 5. 1, 2, 3, 4, 5. And 5. 1, 2, 3, 4, 5. And it's got the same shape. Oh boy, what the heck is that? How did I do that? That wasn't good. Shape, except it does a different starting point. And that's what we're going to kind of focus on here. The starting point, which we said was -4 and 2. How did the starting point shift? Well, it went 4 this way and up 2. So left 4, up 2. And if this looks at all familiar to our vertex form, which we talked about with parabolas, and we just kind of talked about how the similarities between a square root and a parabola, it's half of a parabola, so obviously there's some similarities here. How can you determine the starting point of the function? Well, it's in the equation, right? 4 there, 2 there, except it's always the opposite. So we can determine it from the equation. And if we have the square root of x plus 4 plus 2, this guy right here is the opposite x value. I'm so glad I have so much room to write. Not sure what my little scribble is here. And this right here is the y value. So remember that. All right, so now we introduce a square root function with obviously a little bit underneath the square root and then a little bit more and then a negative, and we're going to key on this here for this example. But let's kind of build on what we did from last time. Let's see if we can do the starting point. So obviously the number inside of the square root is the opposite, and it's the x value. So that's going to be -3, and then the number outside of it is the y value, so there's 2. So we can get that just by looking at the equation. So this means we're going to go 3, 1, 2, 3 to the left, up 2. That's where it's going to start. So that's a little bit of what we talked about last example. Now for this one, we're going to put this in and kind of build our table based on that starting point. So y equals, I'm going to clear out whatever's in the calculator. Goodbye to you. And use the negative button. That one's different than using subtraction. I'm going to go second square root. I'm going to say that it's x, and I already forgot, plus 3, get out of the square root, so arrow to the right, and plus 2. All right, once you get that far, second table. Now that starting point's important with the calculator because it kind of tells you where the values aren't errors. So at -3 is where you would pick this up because anything before that is going to be an error. We got whole numbers here at -2 and 1, so let's use those. -2 and 1. And we've got 1, 0 as another value to plot. You don't always have to go in order. I know that with linears, we're so used to plotting every single one because they're always whole, but we don't have to plot the negative, we don't have to plot the decimal values. Come on, calculator. 6, -1. We got room for one more spot here. You can do it. I don't want to go too far. 13 and -2. Now clearly 13 is not a perfect square, but because we're adding 3 to it inside the square root and then adding 2, it's not always going to be a perfect. So we end up with a upside down square root function. It's going to be just the y values that are decreasing. X values are greater than or equal to negative